On a computer screen, every object has a position. Even something simple, like this red square, needs a way to describe where it is. We use a coordinate system to do that. The system begins with a point called the origin. From the origin, we define two directions: horizontal, called x, and vertical, called y. Every position on the screen can be described using two numbers: how far to the left or right, and how far up and down from the origin. As the square moves to the right, the x value increases. When it moves back towards the origin, the x value decreases. As it continues past the origin to the left, the x values become negative. When the square moves far enough left, it goes out of view. But its position is still defined by its x value. The coordinate system extends beyond what we can see on the screen. The same idea applies in the vertical direction. Moving upward increases the y value. Moving back towards the origin decreases it. As the square continues downward past the origin, the y value becomes negative. When it moves far enough down, it goes out of view, but its position is still defined. The screen only shows part of a larger coordinate system. Even when the square is not visible, its position is still described by its coordinates. Now we extend this idea into 3 dimensions. The square becomes a cube, adding depth. A third direction is introduced called the z-axis. The z-axis measures how far an object is in front of or behind the origin. Now every position is described using 3 numbers: x, y, and z. These 3 directions follow a standard orientation called a right-hand coordinate system. Use your right hand. Your thumb points to the right in the positive x direction. Your index finger points in the positive y direction, upwards. And your middle finger extends in the positive z direction, towards you out of the screen. Along the x-axis, the motion works just as it did in 2 dimensions. Moving to the right increases x. Moving to the left decreases x. Moving to the left past the origin makes x negative. Along the y-axis, moving upward increases y. Moving downward makes it decrease. Moving downward past the origin makes y negative. The z direction describes depth. Moving towards you increases the z value. As the cube moves closer, it appears larger. When it continues to move forward past the camera's position, it moves out of view, but its z value continues to increase. As it moves back towards the origin and then away from you, the z values can become negative. As before, the coordinate system extends beyond what we can see. Earlier, the square moved out of view in 2 dimensions. Here, the cube moves out of view in depth. In both cases, the coordinates still describe its position. In 3 dimensions, all 3 coordinates can change at the same time. A position in space is defined by x, y, and z together. So far, we've focused on the object, but the viewer also has a position in space. As the camera moves around the cube remains fixed at the origin. The coordinate system does not move, only the point of view changes. From different positions, the same object can appear very different, even though its coordinates stay the same. In this view, the observer is located in front of the origin, in the region where x, y, and z are positive. That is why moving toward the viewer corresponds to increasing z. Using this system, a computer can describe any position in space, whether it is visible or not, using three numbers, x, y, and z.